On a humid August morning in 1944, inside a cramped workshop at Tachikawa Airfield outside Tokyo, Chief Engineer Tanaka Yoshio stood motionless before a workbench cluttered with measuring instruments, slide rules, and a single classified document that had arrived from Imperial General Headquarters 3 days earlier. The paper trembled slightly in his hands, not from age or poor handling, but from the weight of what it contained: intelligence photographs, salvaged wreckage analysis, intercepted radio transmissions, and numbers that made no sense, numbers that violated every principle of aeronautical engineering he had spent 2 decades mastering. The Boeing B-29 Superfortress, according to this report, could carry 20,000 pounds of bombs across thousands of miles of ocean, strike Japanese cities with devastating precision, and return safely to bases in the Marianas. 20,000 pounds. Tanaka set the document down carefully and turned toward the window, where, beyond the tarmac, he could see rows of Mitsubishi G4M bombers, the pride of the Imperial Japanese Navy, their sleek fuselages gleaming in the morning sun. Each one, he knew intimately, could carry barely 2,000 pounds of ordnance under optimal conditions. The American bomber carried 10 times that weight. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. But it was not merely the payload capacity that had kept Tanaka awake for 72 consecutive hours. It was the engineering paradox hidden within those numbers, a paradox that suggested the Americans had solved problems Japanese aviation had deemed unsolvable. And in that moment, staring at the distant bombers that suddenly seemed as fragile as paper lanterns, Tanaka understood with cold, mathematical certainty that Japan was fighting an enemy whose industrial capabilities existed in a different dimension of warfare altogether. To understand what Chief Engineer Tanaka was confronting, we must first understand the world from which Japanese bomber design had emerged. In the mid-1930s, as tensions escalated across Asia and the Pacific, the Imperial Japanese Army and Navy issued ambitious requirements for long-range bombers capable of projecting power across the vast distances of China and the Pacific Ocean. The solution was elegant, but fundamentally constrained. Japanese engineers, working with limited access to strategic materials like aluminum and high-octane aviation fuel, designed aircraft that prioritized range above all else. The Mitsubishi G4M, codenamed Betty by Allied forces, first flew in October of 1939 and entered service in 1941. It was, by any measure, an impressive achievement. With twin Mitsubishi Kasei 14-cylinder radial engines generating 1,500 horsepower each, the Betty could reach speeds of 265 miles per hour and fly over 3,700 miles on internal fuel. Its range was extraordinary for the period, allowing Japanese naval aviation to strike targets across enormous oceanic expanses that no other bomber could reach. But that range came at a devastating cost. To achieve such distances, Mitsubishi's engineers had made a calculated trade. They eliminated armor protection for the crew. They refused to install self-sealing fuel tanks, despite knowing that American and British bombers had adopted this critical safety feature. And, most significantly, they restricted the bomb load to approximately 1 ton, 2,200 pounds, barely more than what medium bombers of other nations could carry. The philosophy was clear. Japan needed bombers that could fly farther than anyone else, and every pound of armor, every ounce of redundant structure, every inch of protective plating was sacrificed to extend that range by mere kilometers. American pilots, encountering the Betty in combat, quickly nicknamed it the flying cigar or the one-shot lighter, because a single burst of .50 caliber fire into the unprotected fuel tanks would ignite the aircraft instantly, turning it into a flaming coffin before the crew could even react. The Imperial Japanese Army's heavy bomber, the Nakajima Ki-49, designated Helen by the Allies, suffered similar constraints. First flown in August of 1939, the Helen was intended to replace the earlier Ki-21 and serve as Japan's frontline heavy bomber, Powered by twin Nakajima radial engines producing 1,450 horsepower each, it could carry the same 2,200-pound bomb load as the Betty and had a respectable range of 1,800 miles. But like the Betty, it was chronically underpowered, vulnerable to enemy fighters, and incapable of carrying payloads comparable to American or British bombers in its class. Japanese engineers were not incompetent. They were working within constraints that American designers never faced. Japan's industrial base in 1944 produced roughly 10% of the steel that American factories generated. The nation had virtually no domestic oil, relying entirely on imports that Allied submarines were systematically destroying. High-grade aluminum alloys were scarce. Advanced aviation engines capable of generating 2,000 horsepower or more existed only in experimental prototypes. Every Japanese aircraft was a masterpiece of doing more with less, of squeezing maximum performance from minimal resources. Tanaka himself had contributed to this philosophy. He had personally overseen modifications to the G4M that reduced weight by eliminating redundant structural members. He had argued successfully for thinner skin panels to save aluminum. He had calculated, down to the kilogram, how much range could be gained by removing crew armor. These were not mistakes. They were rational decisions made by brilliant engineers facing impossible material constraints. But now, holding that intelligence report, Tanaka was confronting the reality that those rational decisions had produced aircraft that were, compared to the B-29, primitive. The B-29 Superfortress was not simply a bigger bomber. It represented a completely different philosophy of air warfare, one that Japanese industry could never have replicated even if given unlimited time and resources. The American bomber was designed from the beginning as a weapon system, not merely an aircraft. Boeing's engineers, working from a 1939 Army Air Corps specification, had created a machine that operated at the absolute cutting edge of every aeronautical discipline. 4 Wright R-3350 duplex cyclone turbo-supercharged radial engines, each generating 2,200 horsepower, drove the 99-foot-long bomber to speeds exceeding 350 miles per hour at altitudes above 30,000 feet. The fuselage was fully pressurized, allowing the crew to operate in shirt sleeves at altitudes where Japanese pilots struggled in bulky oxygen masks. The wingspan stretched 141 feet, supporting a maximum takeoff weight of over 60 tons, nearly double that of Japan's heaviest bombers. But the payload capacity was what stunned engineers like Tanaka. 20,000 pounds, maximum, 9 tons of bombs. In practical terms, this meant a single B-29 could deliver the destructive payload of 10 G4M Betty bombers in one sortie, and it could do so while flying higher, faster, and farther than any Japanese interceptor could effectively engage. The Betty's 2,200-pound bomb load, which Japanese planners had considered adequate for tactical strikes against shipping and coastal installations, now seemed almost laughable when measured against what the Americans had deployed. The disparity was not merely quantitative, it was qualitative, revealing a chasm in industrial capability that no amount of pilot skill or tactical brilliance could bridge. When American factories at Boeing's plants in Wichita, Renton, and the Bell facility at Marietta began mass-producing B-29s, they were not simply building bombers. They were demonstrating a manufacturing capacity so overwhelming that Japan, even at the height of its power, could produce in an entire year what American assembly lines generated in weeks. Consider the economics. A single B-29 cost approximately $640,000 to produce, roughly 5 times the cost of a British Lancaster and 10 times the cost of a G4M. Yet, the United States built nearly 4,000 of them between 1943 and 1946. Japan, during the same period, produced approximately 2,400 Betty bombers total and fewer than 820 Ki-49 Helen bombers, and even those production numbers represented an industrial mobilization that pushed Japanese manufacturing to its breaking point. Tanaka understood these numbers intimately. He had visited factories where workers labored 16-hour shifts to assemble aircraft from components salvaged from damaged planes. He had seen engineers improvising replacement parts from scrap metal because new aluminum was unavailable. He had calculated over and over how to stretch materials that were already stretched beyond reasonable limits. And now he was being asked to analyze an enemy bomber that carried payloads his nation's aircraft could never hope to match. But the most terrifying aspect of the B-29 was not visible in the photographs or wreckage analysis. It was the implication behind the numbers. The Americans had designed this bomber years before Pearl Harbor, before the Pacific War had even begun. The Wright R-3350 engines, despite their notorious tendency toward overheating, were refined through thousands of test hours and multiple engineering modifications. The pressurized cabin system required innovations in sealing technology that Japanese manufacturers had never attempted. The remote-controlled gun turrets, linked through a centralized analog fire control computer, represented electronics integration that Japan's aviation industry was a decade away from mastering. Every system, every component, every design choice reflected an industrial ecosystem that could support such complexity. American factories didn't just build B-29s, they built the machine tools that built the components that assembled the bombers. They produced the aluminum alloys in quantities measured in millions of tons. They refined the aviation gasoline in volumes that exceeded Japan's entire annual petroleum imports. They trained tens of thousands of workers in precision manufacturing techniques and deployed them across dozens of facilities spread across a continent safe from enemy attack. Japan had none of this. Japanese factories, by 1944, were struggling to maintain production of existing aircraft designs, let alone develop new ones. Fuel shortages meant that even when bombers rolled off assembly lines, there was insufficient gasoline to fly training missions. Skilled workers were being conscripted into infantry units to defend Pacific Islands. Strategic bombing had begun to degrade the industrial infrastructure itself, forcing production underground into dispersed facilities that could never match centralized factory efficiency. And Tanaka, standing in his workshop at Tachikawa, understood that the B-29 was not merely a weapon, it was a message. It was American industry announcing to Japan that the war had moved beyond tactical considerations of courage, training, and battlefield ingenuity into a realm where industrial capacity determined victory as surely as any military engagement. The bombers, flying over Japanese cities, were not just delivering explosives, they were delivering a mathematical proof that Japan had lost the industrial war before the first shot was fired. As dusk settled over Tachikawa airfield, Tanaka finally lifted his gaze from the intelligence report and looked once more at the rows of Betty bombers parked on the tarmac. They still looked impressive, their aluminum skins reflecting the fading sunlight, their twin engines promising speed and range. But now he saw them differently, not as weapons capable of projecting Japanese power, but as artifacts from an earlier era of warfare, beautiful but obsolete, elegant but insufficient. The enemy had built a bomber that rendered everything Japan had created irrelevant, and there was no engineering solution, no tactical innovation, no amount of pilot courage that could change that fundamental equation. The door to his workshop opened, and a junior engineer entered carrying another stack of reports, reconnaissance observations, damage assessments from recent B-29 raids, projections of American bomber production for the next 6 months. Tanaka accepted the documents without speaking and set them on the workbench, beside the payload calculations he had been reviewing. 20,000 pounds. The number had lost its abstract quality. It was now a concrete reality, measured in the thousands of buildings destroyed across Tokyo, Osaka, and Nagoya. It was measured in the shrinking capacity of Japanese industry to resist, and most of all, it was measured in the growing certainty among engineers like Tanaka that they were witnessing not just Japan's military defeat, but the overwhelming victory of a manufacturing philosophy that Japan could never have matched. The following morning, Tanaka was summoned to a classified briefing at the Imperial General Headquarters in central Tokyo. He arrived before dawn, passing through multiple security checkpoints, his identification papers scrutinized by military police whose expressions revealed nothing. The meeting room was austere, lit by a single overhead lamp that cast harsh shadows across the faces of the dozen men already assembled. Senior engineers from Mitsubishi, Nakajima, and Kawasaki sat alongside Army and Navy aviation staff officers, their uniforms crisp despite the early hour. No one spoke as Tanaka took his seat. At precisely 6 o'clock, a colonel from the Army's Technical Air Arsenal entered, carrying a leather case. He placed it on the table with deliberate care and withdrew several manila folders, each stamped with red characters indicating the highest classification level. The colonel's voice was measured, almost clinical, as he began speaking. The Americans, he explained, had lost several B-29s to mechanical failures over Japanese-held territory in the past 6 months. Wreckage had been recovered, components had been analyzed, measurements had been taken, and what Japanese engineers had discovered was not merely troubling, it was, in his words, revelatory. The colonel opened the first folder and extracted a series of photographs. They showed sections of the B-29's wing structure, aluminum spars thicker than any Japanese bomber utilized, ribs positioned at intervals that seemed wastefully close together, skin panels that appeared unnecessarily heavy. An engineer from Nakajima raised his hand and asked the obvious question. Why would the Americans over-engineer the structure so dramatically? Why add weight that reduced performance? The colonel's answer came slowly, as if he was still processing the implications himself. Because, he said, they could afford to. Because structural integrity was never a constraint they had to compromise on. Because their factories produced so much aluminum that adding an extra ton of weight to ensure the aircraft survived combat damage was simply standard practice. Tanaka felt something cold settle into his stomach. He had spent his career calculating how to remove grams from aircraft structures. The Americans were adding tons. The next photograph showed the Wright R-3350 engine, partially disassembled. The colonel pointed to specific components. The crankcase was machined from a single forging, not assembled from cast sections like Japanese engines. The supercharger housing used alloys that Japanese metallurgists had only read about in pre-war technical journals. The fuel injection system incorporated precision-machined parts with tolerances measured in thousandths of an inch, far tighter than anything Japanese factories could maintain in mass production, and, most significantly, the engine was designed to be disposable. After a certain number of flight hours, American crews simply replaced the entire engine rather than attempting repairs. Disposable engines. The concept was almost incomprehensible to Tanaka. Japanese maintenance crews worked miracles keeping worn-out engines operational, cannibalizing parts from damaged aircraft, hand-filing components to maintain minimal tolerances. The idea that the Americans would discard a perfectly functional engine simply because it had reached its design life spoke to a manufacturing abundance that Japan could not even conceptualize, let alone replicate. But the colonel was not finished. He produced another photograph, this one showing the B-29's bomb bay. It was cavernous, stretching nearly the entire length of the fuselage between the wings, with structural hardpoints capable of supporting ordnance in multiple configurations. 20,000 pounds. Maximum capacity, the colonel reiterated, but the nominal combat load was typically 12,000 pounds, carried over distances exceeding 1,500 miles. A naval officer interjected. Surely, he suggested, these payload figures were exaggerated. Surely, no aircraft could carry such weight and still maintain operational performance. The colonel's response was to produce damage assessment reports from the March 10th incendiary raid on Tokyo. 334 B-29s had participated in that single mission. Intelligence estimated they had dropped over 1,700 tons of M69 incendiary cluster bombs across 16 square miles of the city, 1,700 tons. In one night, from one raid, the numbers represented a destructive capacity that exceeded the entire bomb tonnage Japan's bomber force could deliver in a month of continuous operations. The room fell silent. Tanaka looked around at the other engineers, seeing his own realization reflected in their faces. They had all believed, at some level, that Japanese technical ingenuity could compensate for material disadvantages, that superior pilot training, better tactics, more efficient designs could bridge the gap. The photographs and reports spread across the table demonstrated that this belief was fantasy. The Americans had not simply outproduced Japan, they had redefined what production meant. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The briefing continued for 3 hours. The colonel methodically documented every aspect of B-29 superiority. The pressurized cabin system that allowed crews to operate comfortably at altitudes where Japanese pilots experienced hypoxia, even with oxygen equipment. The analog fire control computers that coordinated defensive turrets with accuracy no human gunner could match. The radar bombing systems that enabled precision attacks through cloud cover and darkness. The auxiliary power units that provided electrical power independent of the main engines. The list went on, each item representing not just a technical innovation, but an entire industrial ecosystem capable of supporting such complexity. When the briefing finally concluded, the colonel asked a question that hung in the air like smoke. Given what you now understand about American bomber capabilities, is there any technical solution Japan could implement to counter this threat? The engineers exchanged glances. One suggested improved interceptor aircraft with higher altitude performance. Another proposed enhanced anti-aircraft artillery. A third mentioned the possibility of ramming attacks or specialized anti-bomber weapons. But Tanaka, speaking for the first time that morning, cut through the speculation with brutal honesty. There was no technical solution, he said quietly. The problem was not engineering, it was industrial capacity. Japan could not build bombers to match the B-29 because Japan did not possess the material resources, the manufacturing infrastructure, or the supply chain depth that American production required. The room remained silent for a long moment. Then the naval officer spoke again, his voice tight with frustration. So, you are saying we simply accept defeat? That we abandon any attempt to match their capabilities? Tanaka shook his head, slowly. He was not advocating surrender, he explained, but clarity. Japan could continue building Betty bombers and Helen bombers, could continue sending them on missions, could continue fighting with everything available, but they needed to understand that they were not competing on equal terms. They were facing an enemy whose single bomber could deliver more destructive power than an entire squadron of Japanese aircraft, whose production capacity exceeded Japan's by an order of magnitude, and whose technological sophistication represented years of development that Japan, under wartime constraints, could never replicate. The meeting adjourned without resolution, the participants filing out in subdued silence. Tanaka remained behind, studying the photographs one final time. His eyes lingered on an image of the B-29's cockpit, with its array of instruments, its comfortable seats, its pressurized environment. He thought of Japanese bomber crews flying in unpressurized cabins where temperatures could drop to 30 below zero, wearing bulky flight suits and oxygen masks, manually calculating navigation while exposed to enemy fire through unprotected positions. The contrast was not merely technical. It was philosophical, that the Americans designed their aircraft to bring their crews home. Japan designed its aircraft to accomplish the mission regardless of crew survival. In the days following the briefing, Tanaka threw himself into a project that he knew was ultimately futile, but felt compelled to pursue. He began designing a theoretical Japanese heavy bomber capable of matching B-29 performance. It was an exercise in understanding constraints, in mapping the boundaries of what Japanese industry could theoretically achieve. The specifications grew on his drafting table like an accusation. To carry 10,000 pounds of bombs over 1,500 miles would require engines generating at least 1,800 horsepower each. Japan could build such engines, barely, but only in limited numbers, and with reliability issues that plagued every high-performance design. To operate at 30,000 feet would require pressurization systems that Japanese manufacturers had never attempted in production aircraft. The technology existed in theory, but implementing it across dozens or hundreds of bombers would require manufacturing precision and quality control that Japanese factories, by 1944, could no longer maintain. To incorporate self-sealing fuel tanks and crew armor would add weight that demanded even more powerful engines, creating a spiral of requirements that quickly exceeded available materials. And even if all technical challenges were overcome, the production timeline would stretch years into the future. Years Japan no longer had. But it was the final calculation that brought Tanaka's theoretical design crashing into reality. The aluminum requirement. A single aircraft matching his specifications would require approximately 18 tons of high-grade aluminum alloy. Japan's total aluminum production in 1944 was estimated at roughly 140,000 tons annually, and most of that was already committed to existing aircraft production, naval construction, and other military needs. To build 100 such bombers, Japan would need to divert 1,800 tons of aluminum, representing more than 1% of annual production, and 100 bombers, against the thousands the Americans were deploying, would accomplish nothing. Tanaka set down his drafting pencil and stared at the calculations covering his desk. The numbers were unforgiving. They demonstrated with mathematical certainty that Japan could not build a strategic bomber force capable of challenging American air power. Not because Japanese engineers lacked skill, not because the designs were flawed, but because the industrial foundation required to support such an effort simply did not exist. The Americans could afford to build bombers that carried 9 times the payload because they had 9 times the industrial capacity, and that disparity was growing, not shrinking, with every month the war continued. Outside his workshop window, Tanaka could hear the distant drone of air raid sirens. Another B-29 raid was approaching, the third that week. He watched as ground crews scrambled to disperse aircraft, knowing the effort was largely symbolic. If the American bombers wanted to destroy Tachikawa airfield, they would destroy it. Japanese anti-aircraft fire was largely ineffective against aircraft operating above 25,000 feet. Japanese fighters, increasingly hampered by fuel shortages and pilot attrition, could mount only token resistance. The defenses that had once protected the home islands were crumbling under the weight of an aerial assault that Japan had no capacity to counter. The sirens grew louder. Tanaka gathered his papers and prepared to move to the shelter, but his eyes were drawn once more to the Betty bombers parked on the tarmac. In the morning light, they still looked formidable, their clean lines suggesting speed and purpose, but he knew now what they truly represented. Not strength, but desperation. Not capability, but the illusion of capability. They were weapons designed for a different war. A war where range mattered more than payload, where tactical strikes against naval targets could influence campaign outcomes, where Japanese forces operated on offense rather than defense. The war had changed. The B-29 had changed it. And Japan, for all its courage and determination, lacked the industrial capacity to adapt. Inside the shelter, as the ground trembled from distant explosions, Tanaka thought about the other engineers from the briefing. They had all seen the same photographs, studied the same reports, understood the same terrible mathematics, and they had all, like him, returned to their workshops to continue working on aircraft that were already obsolete. Not because they believed those aircraft could turn the tide, but because there was nothing else to do. Japan would continue building bombers, pilots would continue flying them, crews would continue dying in them, and the B-29s would continue reducing Japanese cities to ash, their 20,000-pound payloads falling with mechanical precision, delivered by an industrial machine that Japan had never had any hope of matching. The all-clear sounded an hour later. Tanaka emerged from the shelter to find the airfield largely intact. This raid had targeted industrial facilities in Yokohama, 20 miles distant. But the message was clear. The Americans could strike anywhere, anytime, with impunity, and there was nothing Japan could do to stop them. Back in his workshop, Tanaka looked once more at his theoretical heavy bomber design. It was technically sound, carefully calculated, beautifully proportioned, and it was completely irrelevant. He folded the drawings carefully and placed them in a file cabinet, knowing he would never open it again. The disparity between Japanese and American bomber capabilities was not a problem that could be solved with better engineering. It was the visible manifestation of a war between two nations whose industrial capacities existed in different universes. Japan built aircraft from scarce resources, carefully husbanding every kilogram of aluminum, every liter of fuel, every hour of skilled labor. America built aircraft from abundance, adding weight for safety, incorporating redundancy for reliability, replacing entire engines rather than repairing them. One approach was born from necessity, the other from luxury, and in total war, luxury was a weapon more powerful than any bomb. Tanaka remained at his desk long after the other workers had departed, the workshop illuminated only by a single lamp. He thought about the young pilots he had met, the ones who flew the Betty bombers on missions they knew were likely suicidal. They deserved better aircraft. They deserved armor protection and self-sealing tanks and the thousand small design choices that prioritized crew survival. But giving them those things would have meant reducing range, cutting payload, accepting limitations that Japanese strategic planning could not accommodate. So the Bettys flew without protection, and young men died in flames, and engineers like Tanaka carried the weight of knowing their designs had contributed to those deaths. But even that guilt was, in a sense, obsolete, because the B-29 had demonstrated that the entire framework of Japanese bomber design was flawed from the beginning. The Americans had proven that it was possible to build bombers with both long-range and heavy payload, with both crew protection and operational performance, with both technical sophistication and manufacturing reliability. They had proven it by building thousands of them and flying them across the Pacific to destroy Japan's cities with methodical efficiency. And Japan, faced with this demonstration of industrial supremacy, could do nothing but watch and count the cost. Tanaka finally extinguished the lamp and walked out into the darkness. Above him, stars were visible through gaps in the smoke that perpetually hung over Tokyo. Somewhere beyond those stars, beyond the horizon, American factories were producing more B-29s. Tomorrow, those bombers would fly. Tomorrow they would carry their 20,000-pound payloads across the Pacific. Tomorrow, Japanese cities would burn. And there would be nothing Chief Engineer Tanaka Yoshio, or any engineer in Japan, could do to change that equation. The weeks that followed the classified briefing brought a subtle but unmistakable shift in the atmosphere at Tachikawa Airfield. Engineers continued their work with the same diligence, the same attention to technical detail, but conversations in the workshops and design offices carried a different tone. Whereas once they had debated solutions, they now discussed inevitabilities. Where once they had proposed improvements, they now documented limitations. The discovery of the B-29's true capabilities had not broken their spirit, but it had stripped away the comfortable illusions that had sustained morale through the darkest periods of the war. Tanaka found himself spending more time with the maintenance crews, the men who worked through the night, repairing battle-damaged aircraft with whatever materials could be scavenged. These were practical men, uninterested in theoretical designs or strategic calculations. They understood machinery in immediate, tactile terms. When Tanaka asked a senior crew chief about his thoughts on the B-29, the man's response was blunt and unvarnished. "We patch holes in Bettys where 50 caliber rounds went through the fuel tanks. The whole aircraft reeks of aviation gasoline, and we know that one spark would turn it into an inferno. We do it because there's no choice. But when I hear about the American bomber, carrying armor and self-sealing tanks and pressurized cabins. I don't feel anger, I feel envy. They care about bringing their crews home. We just care about getting the mission done. The crew chief's words stayed with Tanaka because they articulated something he had been reluctant to admit. The B-29 represented not just superior industrial capacity, but a fundamentally different value system. American strategic bombing doctrine, for all its destructiveness, was built on a foundation that treated aircrew lives as valuable assets worth protecting through engineering. Japanese doctrine treated aircrew lives as expendable resources to be consumed in pursuit of mission objectives. Both philosophies could be defended in their own terms, but only one could be sustained across years of attritional warfare. Only one could maintain pilot morale when losses mounted. Only one could keep experienced crews alive long enough to train the next generation. By late September of 1944, the frequency of B-29 raids had increased dramatically. The Marianas bases were fully operational now, and hundreds of superfortresses were arriving monthly from American factories. Japanese radar stations tracked their approach with helpless precision, reporting formations of 50, then 100, then 200 bombers streaming toward the home islands at altitudes where most Japanese interceptors struggled to operate. The few fighter units that managed to engage reported the same dispiriting results. The American bombers flew in tight defensive formations, their remotely controlled turrets creating overlapping fields of fire that shredded attacking fighters before they could close to effective range. Tanaka received regular reports from the technical air arsenal documenting these engagements. One report described a fighter attack on a B-29 formation over Osaka. 8 Kawasaki Ki-61 fighters, among Japan's best interceptors, had climbed to engage. 3 were shot down by bomber defensive fire, 2 more were damaged and forced to withdraw. The remaining 3 managed to close within firing range and claimed hits on 1 bomber, but photographic reconnaissance the following day showed all American aircraft had returned safely to their bases. 8 fighters committed, 3 destroyed, 2 damaged, 0 enemy losses. The mathematics of attrition were brutal and unambiguous. What haunted Tanaka was not just the tactical defeats, but the strategic implications hidden within them. Every fighter lost represented resources Japan could barely replace. Aluminum that could have built 2 or 3 more aircraft was consumed in a single loss. Pilots with hundreds of hours of training were killed before they could pass their skills to new recruits. Aviation fuel, already scarce, was burned in defensive sorties that accomplished nothing. Meanwhile, the Americans were losing bombers at a rate of perhaps 2 or 3% per mission, losses they could absorb indefinitely, while Japan's defensive capability eroded with each engagement. The industrial disparity had created a war of attrition where both sides traded losses, but only one side could afford the trade. It was economic warfare in its purest form, and Japan was losing not because its warriors lacked courage or its engineers lacked skill, but because its factories could not match American production. The B-29, with its 20,000-pound payload and its sophisticated defensive systems and its expendable engines, was the physical manifestation of that industrial supremacy. Every raid was not just an attack on Japanese cities, it was a demonstration that American manufacturing capacity could sustain this level of destruction indefinitely. In early November, Tanaka was assigned to examine wreckage from a B-29 that had crashed after suffering catastrophic engine failure on approach to its Marianas base. Japanese reconnaissance aircraft had photographed the wreck before American salvage crews reached it, and those photographs revealed details that previous intelligence had missed. The bomb bay doors, even in the crashed state, showed sophisticated hydraulic mechanisms far more complex than anything on Japanese bombers. The landing gear struts were massive, engineered to absorb the shock of landing a 30-ton aircraft repeatedly without failure. And, most tellingly, the engine that had failed showed signs of having been operated far beyond its rated performance envelope, pushed into emergency power settings that Japanese engines could never sustain. The crashed bomber told a story of engineering margins and safety factors. The Americans built their aircraft to tolerate abuse, to survive pilot error, to continue operating when individual systems failed. Japanese aircraft built to minimum weight specifications with no margin for error offered no such forgiveness. A Betty bomber, pushed beyond its performance limits, would simply disintegrate. The B-29, pushed beyond its limits, might lose an engine, but would limp home on the remaining three. This philosophical difference in design, multiplied across thousands of aircraft, determined who survived and who did not. As 1944 drew to a close, the scope of American strategic bombing expanded beyond anything Japanese planners had anticipated. The November 24 raid on Tokyo involved over 100 bombers striking aircraft factories and industrial facilities. The December raids targeted Nagoya's manufacturing districts. By January of 1945, B-29s were flying missions every few days, sometimes in formations exceeding 200 aircraft, dropping thousands of tons of high-explosive and incendiary bombs across Japanese industrial centers. The cumulative damage was staggering. Factories that had struggled to maintain production under material constraints were now being systematically destroyed. Transportation networks were disrupted. Civilian morale, already strained, began to crack under the relentless aerial assault. Tanaka watched the destruction spread across the map like a slow-motion catastrophe. Each raid represented payload deliveries the Japanese bombers, even in their greatest concentrations, could never match. A single B-29 formation of 200 aircraft could drop 4,000 tons of bombs in a single mission. Japan's entire bomber force, if committed simultaneously and assuming perfect conditions, might deliver 400 tons. The disparity was 10 to 1, and it was being demonstrated in fire and rubble across every major city in the home islands. But perhaps the most psychologically devastating moment came not from a raid or a briefing, but from a casual comment by a captured American airman. In February of 1945, a B-29 crew was forced to bail out over Japanese territory after their aircraft suffered severe damage from anti-aircraft fire. The surviving crew members were brought to Tokyo for interrogation, and Tanaka, as a senior aviation engineer, was permitted to observe. When the American pilot was asked about the psychological impact of flying such dangerous missions, his response was matter-of-fact. Dangerous? Sure. But we know the B-29 can take a beating. We know we've got good odds of making it home. And we know that even if we don't, there's 100 more right behind us finishing the job. That confidence, that casual certainty of industrial backing was more demoralizing than any technical specification. The American pilot wasn't bragging. He was simply stating facts. His survival depended not just on his skill or his aircraft's performance, but on the knowledge that American production was inexhaustible, American technology was superior, and American strategy was winning. Japanese pilots, by contrast, flew knowing that their aircraft were fragile, their fuel was scarce, their replacement training was inadequate, and their sacrifice, however brave, would not change the war's trajectory. Tanaka left the interrogation feeling hollowed out. He returned to his workshop and found a letter waiting from the Naval Technical Arsenal at Yokosuka. They were soliciting proposals for enhanced defensive weapons for the G4M. The letter was courteous, professional, and utterly pointless. Enhanced defensive weapons could not compensate for unarmored fuel tanks. They could not increase payload capacity. They could not close the industrial gap that separated Japanese and American bomber capabilities. The letter represented institutional momentum, the bureaucratic reflex to keep working on problems long after those problems had been rendered irrelevant by larger strategic realities. He drafted a response that he knew would never be sent. In it, he explained with careful technical language that the Betty bomber was not a viable platform for modification, that resources spent improving obsolete aircraft would be better directed toward civil defense, dispersal of industrial facilities, anything other than pretending Japanese aviation could compete with American bomber fleets. But he stopped before completing the letter, recognizing that such honesty would accomplish nothing except to demoralize others as he himself had been demoralized. Instead, he wrote a bland, technical response, proposing minor armament modifications, and filed it away with all the other pointless paperwork that accumulated in wartime. The firebombing of Tokyo on March 10, 1945, marked a turning point in the American bombing campaign and in Tanaka's understanding of what the B-29 truly represented. Over 300 bombers participated in that single raid, flying at low altitude in darkness, dropping M69 incendiary cluster bombs across densely packed residential districts. The resulting firestorm killed an estimated 100,000 civilians and destroyed 16 square miles of the city. Tanaka, sheltering in a reinforced bunker at Tachikawa, felt the ground shake from the intensity of the inferno burning 20 miles distant. When he emerged at dawn, the entire eastern horizon glowed orange, and ash fell like black snow across the airfield. The March 10th raid demonstrated several things simultaneously. It showed that American tactics had evolved beyond high-altitude precision bombing toward area incendiary attacks designed to maximize destruction of urban infrastructure. It showed that Japanese air defenses, despite desperate efforts, could not prevent mass bomber formations from operating at will over the home islands. And, most significantly, it showed that the B-29's payload capacity, when loaded with incendiaries instead of high explosives, could deliver devastation on a scale that transcended traditional bombing assessment metrics. The 1,700 tons of bombs dropped that night created destruction equivalent to what conventional strategic bombing might have achieved over weeks or months of sustained raids. In the aftermath, Tanaka was sent to assess damage at several aviation facilities in the Tokyo area. What he saw was not just destruction, but obliteration. Entire factory blocks reduced to twisted steel and ash, machine tools melted into slag, precision instruments destroyed by heat that reached temperatures exceeding 1,000 degrees. The March 10th raid had not merely damaged Japanese industrial capacity, it had erased sections of it permanently, creating gaps in the manufacturing chain that could never be repaired under wartime conditions. Walking through the ruins, Tanaka thought about the payload calculations that had consumed him months earlier. 20,000 pounds per B-29. 334 aircraft in the raid, over 6 million pounds of incendiaries delivered in a single night. The numbers had transformed from abstract specifications into concrete reality, measured in square miles of destruction and thousands of lives lost. And the Americans could repeat this performance tomorrow, and the day after, and the day after that, sustained by factories that had already produced thousands of bombers and would produce thousands more. By April of 1945, organized Japanese aviation had effectively ceased to function as a strategic force. Fuel shortages grounded most training operations. Experienced pilots were being held in reserve for anticipated invasion defense. New aircraft production, disrupted by bombing and resource shortages, had fallen to a fraction of wartime peaks. The Betty bombers that Tanaka had worked on for years sat idle on dispersed airfields, unfueled and increasingly cannibalized for spare parts. They had been rendered irrelevant, not by combat losses, but by strategic obsolescence, by an enemy whose bomber fleet could accomplish in days what Japanese aviation could not accomplish in months. Tanaka spent his final weeks at Tachikawa cataloging and preserving technical documentation, understanding that whatever came after the war would need this institutional knowledge. He worked methodically, filing away design specifications and test reports and the accumulated wisdom of decades of Japanese aviation development. Some of these documents detailed genuine innovations, clever solutions to difficult engineering problems that reflected the brilliance of Japanese designers working under impossible constraints. But all of them, every single design, existed in the shadow of one overwhelming truth. Japan had built beautiful, efficient, elegant aircraft that could not carry enough bombs to win the war. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.